And without further ado, Dimitris is going to... Dimitris Bertsimas, who is, among many things, he's the Vice Provost of Open Learning, but I think here he's the Associate Dean of Business Analytics and Boeing Professor of Operations Research. Dimitris, take it away.
Thank you. Good morning. I'm here as a professor, not the other titles, which is, in fact, if you think about it, the most important aspect of my experience here at MIT. So I'm talking about creating fair and efficient transplant allocation policies. This is work jointly with my colleague, Nikos Trihakis, our doctoral students, Eli and Mora, our postdoc, Tommy, and recently graduated Angelos, and our master student, Jayun. So just as a historical note, Nikos and I have been working in transplantation areas for about 15 years. Although the focus today, what I'm about to present, is work that we have very much completed in the last year after the SERC call. Who here knows much about transplantation? Raise your hand. Not so much. I thought so. So let me give you some perspective. Transplantations in the United States, last year, we had about 50,000 transplants. About 27,000 or so were kidney transplantations. These are people who die and donate their organs. There are also live transplantations, but this is far less common. More than 95% are from somebody who donated the organ when the person died. You see 11,000 livers and so forth. Between kidneys, livers, and hearts, this is the lungs, this is the majority. There are some others as well. So clearly, in many organs, this is a matter of life and death. If somebody, for example, does not have needs transplantation on the liver, you either get a liver or unfortunately, you die waiting. So I'd like to give you some background of the process. So imagine Jane. Jane is 34 years old and has an autoimmune disease. The disease recently damaged her kidneys, leaving her dependent on dialysis. So the blood can be cleared. Typically, this is a 3 times a week endeavor, and in need of a transplant. To receive a transplant, she must enroll on a national waiting list along with 1,000 other patients. So now this is a list, and when a kidney is offered, meaning that somebody has died and the kidney is donated, so according to some criteria that we will discuss, a list is formed, a queue is formed, and Jane enters that queue based on her characteristics. It's not a typical line in the sense that a new kidney changes the priorities because the biological matches are not the same from kidney to kidney. So as a result, when a kidney is donated, all compatible patients are prioritized according to a policy, a national policy. So it acts more like a pool. So now the kidney is, so there is an ordering developed by national policy. We'll discuss about these matters. And then the kidney that is offered first to the first person waiting in that list. The person has an hour to accept or reject. If the person does not accept because he doesn't think that the quality of the organ is appropriate or for other reasons, the offer goes to the second person, and at some point, the kidney is given to a third person. Jane didn't get it this time, so it re-enters the list, and so it goes. Okay, so just to give you a sense, there were about 27,000 last year successful transplantations. The waiting list was about 100,000. So it's the average waiting list people can be in the waiting list for 5 years is not uncommon. So, so what is the key concept? The key concept is that of an organ allocation policy. So this policy determines the priority of an organ transplant. It critically drives aggregate clinical benefit of transplantation and also shapes how benefits are distributed across the population. What is the significance of that? By altering who is likely to receive a transplant, policies might affect reducing the wait list mortality. What is the principal? And I'll see you a concrete example based on some of our earlier work that changing policies might actually affect how many people live and die. Or it could be affect how fairly you distribute transplants across the nation. For example, here's a simple example. Should distance play a role in that? If you have a kidney that needs to, let's say, travel 200 miles or 3,000 miles, does it matter? And how does it matter? And also, it might increase the policy on the number of usable organs. Why is this so? Because as you start offering the kidney, I mean, they have a useful life about 24 hours. If the kidney is not donated within 24 hours, then it might not be viable anymore and is discarded. So if you have a policy that you have very few discarded organs, this might actually affect lives in the future. So clearly you observe that policies might have implications on life and death, ethical aspects, who should have priority. Sometimes who should have priority affects who lives and who dies. It's not a nice to have, it's an important aspect. Just to give you an example from some of our earlier works, Nikos and I and our former student Ted. So this is time, and this is the count of wait list removals that are too sick to transplant or death. Let's say decreased small numbers is a good thing. It meaning that more, less people die in a way. So we have worked. Some of the tools we use in this presentation were used for. This is for lung transplants. It's about 3,500 a year. So the lung policy, based on some of our work, was started in March 2023, and so it has been going on for 2 years. And you observe that this new policy decreased very unfortunate outcomes, death, from around 300 to about 160 or so. So just to demonstrate that these are not innocent aspects, okay? So a 38 decrease reduction, and lung is about maybe 9% of the total transplantations in the country. So how is the national policy created? So national committees made up of doctors, patients, ethicists, and so forth develop policies. And these are dedicated people with a committee involves, multiple times, Nikos and I have presented in this committee, of the order of maybe 20 people. There are 6 such national committees. There is a committee on kidneys, which is, as you have seen, the majority of the transplantations, a heart committee, a lung committee, and more or less ethics committee that talks about general principles and trade-offs, a multi-organ committee, and a liver and intestinal committee. Each committee is separate. It is supported by several entities that HRSA, the health department in the United States, has formed that have certain roles. UNOS, which is a very important committee and very important unit that in many ways implement the national policy. These national policies develop guidelines. UNOS implements. And then there is another important entity, SRTR, which does the analysis of these aspects. You will see today. Now, what is the vision of what we try to do? I gave you, this was a preliminary to give you a little bit of a sense what transplantation is and some of the issues that arise. So we have the following objectives in this work. As you will see, these objectives are not minor, in my unbiased opinion. So we would like to decrease the time to design and evaluate organ allocation policies from years, or what it is today, and I'll tell you more detail, to seconds. In other words, we would like to build a system that once completed, people in the committee, while the committee is happening, can use the system, and when they propose policies, they can figure out the effects without having to wait months and years for the results to come back, which is the current situation. To allow the committees, UNOS, Congress, and the public to evaluate these policies and understand trade-offs. So currently, that's not true. That is, all this knowledge is within the committees and so forth. But let's say, for example, the public wants to understand the effect. That's not feasible. Very importantly, we would like to decrease waitlist mortality. I saw you before an example of such a policy. Would like to unify the design of policies for all organs simultaneously. Currently, one committee meets about kidneys, another committee meets with completely different on livers and so forth. There's no unifying theme. So even the ethical aspects of what we are doing is not by the same people, in other words. And finally, we would like to enable the ability to design and evaluate multi-organs. Today, it's completely, when somebody passes, there are multiple organs that can be donated. But currently, if somebody needs a lung and a heart, for example, how do you evaluate this relative to a lung alone, a heart alone? Two people will be the recipient, but one per. So there are serious ethical issues as well as efficiency issues. A very important component of this is the simulation of the transplant system, because if you want to do something from months to seconds, it has to run very effectively. And this is not a trivial matter. The reason it's not a trivial matter, because when you see a simulation, you know historical data. When this historical data is available, you have to say, if the policy changes, different orderings will happen. And you need to understand what you know is what has happened. What you need to find out, what would have happened for a new policy. So there is a so-called notion of counterfactuals and estimating and so forth. I won't bother you with all the details. But this is not a trivial story. As indicated, the fact that the SRTR, which simulates, takes typically 6 months to complete an investigation of 5 to 10 policies. So in other words, the story is as follows. The committee meets, 5 to 10 minutes, 10 policies are contemplating. They are simulated by SRTR. After 6 months, you get some results. Quite often, new analysis is initiated, another 6 months. Often, changing a policy is a long, multi-year process. That's the current story. So, of course, policymakers have limited information. That's about 6 months. And only few policies are being evaluated. And definitely not online. So, of course, the ideal is to simulate more policies, to also try to explore far more than that, and much faster. So what we've done is we developed a novel algorithm for simulation. This is about 1,000 times faster than the existing. It goes from 6 hours to 14 seconds. 14 seconds is online. If you have a simulation, you can, while the committee is meeting, it can run, if you have an appropriate way of evaluating. So, and it also allows not one policy, thousands of them. So if they have various ideas, this is where AI can help. this is not just because hardware is faster. You have to organize it in a way that is far more intelligent. And then we have generalized, my time is closer, but we also have a way of designing policies, and I will do it in this way. So here are some things. We'd like to minimize wait-list mortality. We have to have many transplants. We have to have pediatric access. You would like to reduce geographic disparity, to reduce blood type disparity, and so forth. The way we do it, our simulation keeps track of all these measures by thousands and thousands of policies, and by having weights, you can optimize this using optimization to be able to optimize that. So this is a system that optimizes, simulates, optimizes, and because we have already pre-calculated thousands upon thousands of policies, the optimization is much simpler. To build this offline, it might take a long time, but online, it's seconds. And the way to support all this is a website which by the end of the month will become available to the nation and the committees that basically allows all these calculations in a way that makes trade-offs and so forth, and gives various metrics for which ethical questions can be addressed. For example, the question I was asking you, the trade-off between if you allow transplantations for longer distances, maybe the wait-list mortality will go down. On the other hand, the discard might be possibly higher because they have to travel. So how do you optimize all these things? And this is because, one, you have the metrics, then you can possibly optimize that. So this is James Alcorn. It's a short video. I don't know. I hope it would work sometimes.
One of our key partners in this has been MIT, or the Massachusetts Institute of Technology. And what MIT has brought to the table is they have brought their expertise in mathematical optimization to the table. MIT is able to radically change the turnaround time for evaluating these different simulations of policy scenarios. What would normally take a couple months to look at a handful of different policy scenarios, MIT is able to let us look at thousands upon thousands of different policy scenarios in a matter of minutes. And so we are able to make these changes much more rapidly, which ultimately means that we're able to improve the system for transplant candidates much more rapidly. One of our key partners in this has been MIT.
To conclude, we have completed this aspect of the design to being able to evaluate tens of thousands of policies. We built this website, which we plan to make available in the end of the month for kidneys, and in the end of the summer for all organs. I gave you an example of wait-list mortality. We have completed and implemented this in the nation, not for writing papers, for lungs. And we are in process, because we are in dialogue for all the committees, we are optimistic that this will also go on for the other organs. We are in progress of designing these policies simultaneously. In other words, the website, you click the organ, and then all of the analysis is unified. And finally, we have started, I will start working on it, on how to evaluate, given we have all this data, how do we evaluate and make ethical decisions between multi-organ transplantations. Thank you.
Awesome. Thank you so much, Dimitris. So we're going to take questions. Quick, a couple of ground rules. We'll get 2 mics going. Nikos, is it going to be you or Angela? Perfect. OK, so I'll maybe start with this side of the room. And what we'll do, we'll have a quick ground rules. I'm afraid it's going to be no follow-ups. It's going to be a single question. And then, yeah, we'll try to get through.
And I'll try to answer them quickly.
Please, yeah. Questions for Dimitris?
There was a question.
Yes. We'll start off. And Angela, could you get somebody on deck for the moment? We'll start with you.
Thanks, really interesting talk. I'm wondering if your simulations have revealed some new interesting trade-offs which were previously unknown.
There are many, but to be able to answer, there are many. In fact, the discussions in the ethics committee discuss exactly that. And the beauty of this is because you have all this data in front of you, it generates new ideas. You say, for example, let's say the pediatric use is lower. What would have happened? Can we do something else? Of course, there's no free lunch. You cannot do anything that fulfills every single obligation, every single thing that you try. But people now have a system that online they can make these decisions. I'll be glad to point you to some papers for all these discussions. Otherwise, it will take us all the time. The lady here.
Yeah, I was curious. Obviously, with simulations, one of the challenges is the data you put into them and the assumptions about the equations that you're using. So I'm just curious how you got the committees to buy into that, or how that process worked.
Years of effort. This is the data that the nation has. This is UNOS data. This is every single thing that has happened. We also simulated. You can simulate and then see the effect on things that you do know. We obviously would increase credibility on that. I mean, as you know, you build credibility with a lot of evidence and so forth. I told you 15 years, we have some credibility on that, and good results. I saw you, when you have a policy that we predicted the mortality would drop 200 deaths, and it happened, well, that's pretty credible, no?
Oh, okay, I have one question.
Where are you?
Oh, she's here.
Oh,
Okay.
I'm here. Yeah, I have a curious one thing. Now in my country, I am from Mongolia. In my country, we have a
Which
very
country?
Mongolia.
Mongolia.
We have a very big scandal in my country currently because one doctor is the prisoner due to the harvesting the many organs from the person who is the donated, and then how it will be regulated by if it's involved in so many stakeholders, for example, doctors and other some part.
How it is. This is a highly regulated
Yeah.
story that has the attention in the higher echelons of the government. So the committees design a policy. These policies as implemented in UNOS. UNOS is the regulator in a way, the one that, obviously I do not know what happens in every single country in the world, but in the United States, I have not, people disagree. Scandals, I have not heard.
Okay, thank you.
So therefore, I do not know what happens in other countries. Other questions? Yes, sir.
Yes, my understanding is that you have a large amount of policies you're looking at, and you make that simulation or decision based on the smaller amount of criteria. The criteria such as like the reduce the mortality of the women.
Travel.
Yeah, you have that list. And what if the priority of the requirement, the criteria changes? And that would change a lot, right? So that the whole thing, simulation will change. My question is that when that happens, or somebody adding some other criteria, and how would that thing change everything? And would that be still like ethical?
What we have found, this has been going on for some time. We know the criteria. There are about 20 of them, right? Now, on these 20 criteria, we have mapped thousands upon thousands of policies to these criteria, right? So then we try to optimize according to these criteria. We have some weight, they can change. Let us build a policy that emphasizes weightless mortality. This is much higher weight than before. We can do that. On the other hand, if at that point they design a 21st criterion that it was never before, we have to go to the drawing board. We cannot, we do many things. Coffee we don't make. So, I mean, you realize this is, if it is within what has been analyzed in the past, and it has been my experience that it's always like that. To find a brand new criterion that nobody has ever thought about, I've never seen it. So, you see what I'm saying. Other questions? Yes?
Yep.
My question is, your criteria are fact or subjective? Like
weightless mortality is a factual. How many people died?
No.
What is the average waiting time?
You said there are at least 10 to 20 criteria apply for each candidate. So I don't believe
Not for each candidate. No. These criteria are for the policy. For example, if I change the ordering, there are 35 more deaths, but but people have to travel 21 more miles, and the number of pediatric transplants goes down. This is not on the patient. This is, as you change the national policy, you affect the aggregate behavior of the system.
But on the slide you show some criteria, like most of them, for me it's a fact, like the blood group, you cannot change the patients.
This is how the wait list, for example, how long have you been waiting for a kidney transplantation matters in your ordering. The sensitization of the characteristics of the organ and characteristics of the patient also matter. So there are criteria of how to order and with what significance, but how the national policy is thinking is what is the effect if you change something to the overall national effect. I hope I'm making myself clear.
Not really, thank you.
Well, but your question is also not as clear as well, I'm sorry to say. So.
Okay, thank you. Are we having a sense, I'm just going to close up, this will be the final question, are we have a sense of what policies are winning out when people are able to identify precisely what their priorities are and then simulate the effects of these policies?
We have, look, the class of policy we are considering is called continuous distribution policies. There has been a lot of debate for decades of what is the class and so forth. The nation has converged on a particular way with what's called continuous distributions with the geographical aspects and so forth. There's no time to explain. But within this class, which is a broad class, this is where we optimize. This is where we and I think there is significant convergence that this is the class. Now, the specific parameters, that's another story. But that's where the nation has converged.
Awesome. Well, thank you so much, Dimitris.